Here's a problem from section 10.3. This is number 1, and they want you to plot each point with the given polar coordinates, and then find the corresponding rectangular coordinates. So you had 4 points, A, B, and C. So these are the points. So what I did was I set up kind of a little polar setup where this is going to be a circle with radius 1 and circle with radius 2, approximately. And we just graph the points, and this is going to be the line, or the diagonal line, which is pi over 4, 45-degree angle. And then we just plot the points. The first one was the square root of 2. So that means I'm going to go out the square root of 2, which is about 1.4, and I'm going to be on this line y, pi over 4. So that rate. The next one is a point 1, 0. The radius is 1. This is in polar form. So my radius is 1, and I'm going to be on the angle 0, so it's just going to be over here. The next one is 0, pi over 2. Well, this is the line pi over 2, 90 degrees, and this is 0 out, so it's just going to be right there. And the last one was, again, on the line pi over 4, the 45-degree angle, but it's negative the square root of 2, so instead of going in the positive direction, I go in the reverse of the negative direction, and that's going to be negative. That's going to be about 1.4 out there. So those are the 4 points. And then they wanted you to find, with the given polar coordinates, find the corresponding rectangular coordinates. So we have to use these conversions. X equals r cosine of theta, y equals r sine of theta, and the tangent of theta equals y over x, and r squared equals x squared plus y squared. So these are our conversions for polar to rectangular. So here's our polar coordinate, and we want to find the x. So the x is equal to r cosine of theta. R cosine of theta. Theta was pi over 4. The cosine of pi over 4 is the square root of 2 over 2. And my r was the square root of 2. So if I multiply the square root of 2 times square root of 2, I get 2 over 2. So I get 1. Then if I want to find y equals r sine of theta. So again, r was square root of 2, and theta was pi over 4. And the sine of pi over 4 is the square root of 2 over 2. So I got 2 times square root of 2 over 2, which is also 1. So this is my point over here, 1, 1. So these points are equivalent. This is polar. This is rectangular. The next one we have the point r is 1, theta is 0. That was our point B. So again, x equals r cosine of theta. R was 1. The cosine of theta, theta was 0. So cosine of 0 is 1. So 1 times 1 is 1. Y equals r sine of theta. Y equals 1 sine of theta, 1 sine of 0. The sine of 0 is 0, so 1 times 0 is 0. So there's your point in rectangular. Letter C, this was the point 0 pi over 2. Again, x equals r cosine of theta. R was 0. Cosine of theta is pi over 2, so that's just going to be 0. Y equals 0 sine of theta. That's again going to be 0, 0, 0. Okay, and the last one, letter D, that was a point negative square root of 2 pi over 4. So again, x equals r cosine of theta, negative square root of 2 times the cosine of pi over 4, negative square root of 2 times square root of 2 over 2, which is just going to be 2 over 2, negative 1. And y equals r sine of theta, or negative square root of 2 sine of theta, that's r. Sine of theta, theta was pi over 4. So negative square root of 2 times the square root of 2 over 2, which is also negative 2 over 2, which is negative 1. So there's your last one. So just have to know these conversion formulas are very important that you remember these, and then just apply them.